Alright, for question 11, we're talking about the change in the weight of an astronaut as she goes into space, as the change in her distance from the surface of Earth changes, which is h in miles. So h is your distance from Earth in miles, and it's changing, and the change in her weight is something that we're looking at here. And so they give you a formula. W sub 0 is the weight on Earth. W is your weight wherever you are in space. H is how high you are from the surface of the Earth in miles. And so we're talking about W sub 0 is 130 pounds, H is 40 miles. The change in H is 12 miles per second. It's being launched into space at a rocket. And so when you write this, the W sub 0 and the 3960 squared are all constants. You can bring them out front. And the denominator, you can bring it up into the numerator and write it with a -2. So when you take the derivative, the constants in front don't change, and the -2 comes out. That becomes a -3, and then you got to follow with the derivative of what's inside. So -2, this to the -3, times the derivative of what's inside, which is just 0, and then 1 h prime, which is just h prime. And now you plug in everything you know, and you crunch it out, and you get your answer there. On this one, you've got a plane traveling at 500 miles per hour. It's 1 mile above a radar station, and at some point it's 2 miles from the plane is the radar station. And they're asking you to find the rate at which the distance between the radar and the plane are changing. What rate? Well, we got x prime, z is constant. We're looking for y prime. Okay, so if z is 1 and y is 2, x is square root of 3, since by Pythagoras. And we know dx dt is 500. We're looking for dy dt. So when you take the derivative, we get 2y prime, we get 2x x prime, and we get 0 for our constant. Plug in everything that we know, we get our answer. Okay, now 15. You've got a street pole. You've got a person who's 6 feet tall. They're walking away from a lamp, and they're currently at 1.40 feet from the pole, and they're walking at a rate of 5 feet per second. They want to know what is the rate of change between the pole and the tip of their shadow. And if you call this first part x and the second part y, you're looking for the rate of change of x plus y. Alright? Well, by similar triangles, you can say 15 relates to 6 as x plus y relates to y. And when you cross multiply and solve for y, you get y equals 2/3 x. Now, if we're looking for the rate of change of x plus y, we can write x plus y in terms of x plus x, 2/3 x. And so we're looking at the rate of change of 5/3 x, which is just 5/3 x prime. We know what x prime is, it's 5, and so we get our answer that way. Alright, number 17, the rate of change of y over the rate of change of x and the rate of change of x. They're asking at what rate is the distance between the cars increasing at 2 hours, so we're looking for the rate of change of z. Well, when they give us y and they give us x, we can figure out what z is just by Pythagoras, so we get x, y, and z. And we got x prime, y prime, we just need to figure out z prime. So we get 2z, z prime, 2x, x prime, 2y, y prime, and you plug in 5 out of the 6 that you know, and you get your answer.